let's meet quadratic equations. What are quadratic equations? Quadratic equations are polynomial equations with degree equal to 2. So that means the highest exponent of the variable must be equal to 2. So it can be written in the form of ax squared plus bx plus c is equal to 0, where a, b, and c are coefficients and x is the variable. So this is x squared and x. You see x is the variable and a must not be equal to 0. So imagine if a is equal to 0, this term will be 0, and this is a linear equation. Okay? So this is the general form of quadratic equations, ax squared plus bx plus c is equal to 0. So what does this mean, right? So it is easier to show by examples. Okay? So from these polynomial equations, which of these are quadratic equations? You may pause if you want to answer it yourself, but let's answer. So 9x plus 2 is equal to 0. Well, here we need the term x squared. We need to have the literal coefficient x squared, right? The term with x squared. So here we don't see x squared anywhere. So this is not a quadratic equation. In fact, we call this a linear equation. Okay, how about this? X squared is equal to 0. We see x squared here. So this is a quadratic equation. X squared plus 2x minus 3 is equal to 0. Yes, this is also a quadratic equation. We see x squared here. Negative 4 plus 9x squared is equal to 0. Yes, the x squared is over here with a is equal to 9. Its numerical coefficient is equal to 9. And for the last example, x squared plus x cubed plus 1 is equal to 0. This is not a quadratic equation. Even though we see x squared here, one of our conditions is that the highest exponent of the variable must be equal to 2. But we have here x cubed, which means the degree of this equation is 3, not 2. Okay? So this is not a quadratic equation. In fact, what we call this is cubic equations. Okay? So these three these three equations are quadratic equations, are examples of quadratic equations. Okay? There are more complicated ones, but we won't talk about them for now. So the roots of quadratic equations, these are the values of the variable that satisfy the equations. For example, x squared is equal to 0. What must be the value of x that will make this equation true? Well, that means x must be equal to 0. Any other value here will make it false, will make it incorrect. So x is equal to 0 is the root or the 0 or solution of this quadratic equation. How about here? X squared plus 2x minus 3 is equal to 0. What are the values of x that will make this equation true? So that is x is equal to 1, right? And or x is equal to negative 3. And we can substitute here. We can substitute x equal to 0 here. So we get 0 squared is equal to 0 and 0 is equal to 0. This is a correct statement, right? Here, we can substitute 1 here. So 1 squared plus 2 times 1 minus 3 is equal to 0. And 1 squared is 1 plus, so let's rewrite it. 1 plus 2 minus 3 is equal to 0. So that means 3 minus 3 is equal to 0 is equal to 0. So this is also true. We can also try negative 3. Let's try here. So negative 3 squared plus 2 times negative 3 minus 3 is equal to 0. So 9 minus 6 minus 3 is equal to 0. And we can easily see that 0 is equal to 0. This is also correct. So x is equal to 1 or x is equal to negative 3. These are the values that will make this equation true. So these are the roots of this quadratic equation. So how about this? How about negative 4 plus 9x squared is equal to 0? So what are the values of x that will satisfy the equation, that is x is equal to 2/3 or x is equal to negative 2/3. Okay, you can also substitute it to double check. Okay, but we won't show it anymore. There's no space anymore. Okay, so how to determine this? How to determine these values? How to determine the roots of the quadratic equations? So there are, we will study 3 methods. So those 3 methods are factoring, completing the square, and quadratic formula. And why do we study this? Let's take this example. So for example, we want to determine the dimensions of our rectangular backyard. And for some weird reason, the only things we know is that the area of this rectangular backyard is 54 meters squared, and the length is longer, 3 meters longer than the width. So for example, let x be the width. And since we know that the area is length times width, right? So we can multiply it x times x plus 3, right? So this is the length. X plus 3 is the length since it's longer by 3 compared to the width. Okay. So if we multiply the width and length together, we will get x times x plus 3, which is the area, which is 54. Right? So let's just not put the unit for now. Okay. We distribute x, we get x squared. X squared plus 3x minus is equal to 54. Then we can rewrite this as x squared plus 3x minus 54 is equal to 0. And we can see this is the format of quadratic equations we talked about earlier, right? And now this we can factor. So what is the factor of this? Well, it is x plus 9 times x minus 6 is equal to 0. And so now, what? So what we can factor them? Well, remember, let me write here in the small part here. If we have a times b is equal to 0, there must be one number here, at least one number here, that is equal to 0. That means this must be a is equal to 0, or if a is not equal to 0, then b must be equal to 0, right? So the same here. X plus 9 is equal to 0, or x minus 6 is equal to 0. So by adding negative 9 both sides, we get x is equal to negative 9, or x is equal to 6. So these are the two values that will these are the two values that satisfy the equation. And since we don't have negative distances, negative width and length, we will consider x is equal to 6. So the width is 6. So this is 6 meters. And the length, since it's 3 meters longer, this should be 9 meters. And we can see the area, 9 meters times 6 meters, is 54 meters squared. So that's it. Okay. Now, if you forget factoring, for example, we already just factored it here. If you forget it, we will see, we will talk about it in the next video.